Here's problem 3812. At what distance could one theoretically distinguish two automobile headlights separated by 1.5 meters? Assume a pupil diameter of 0.5 centimeters and yellow headlights seen at a wavelength of 5 times 10 to the minus 7 meters. Also assume eye fluid has an average index of refraction of 1.33. So we have a distance between the headlights, let's call it y, 1.5 meters. We have a pupil diameter of 0.5 centimeters, so that's going to be 5 times 10 to the minus 3 meters. We have a wavelength of light of 5 times 10 to the minus 7 meters, and an index of refraction in our eye of 1.33. If we're trying to resolve two headlights a distance y apart at some distance from us, L, that would be at some minimum angle, theta, and it's going to be a very small angle. So theta actually would be equal to y divided by L if we look at it on this triangle for a small angle in terms of radians. The Rayleigh condition for resolution is going to be equal to, for a two-dimensional aperture like this, 1.22 times the wavelength of the light in our eye divided by the diameter of the pupil, diameter of the aperture. And this, of course, is going to be equal to y divided by L for small angles. So let's solve this for L. L is going to be equal to y times d over 1.22 times the wavelength in our eye, which is the wavelength divided by n. So this is going to be equal to y times d times n over 1.22 times the wavelength of the light. So that is going to be equal to 1.5 meters times the diameter of the pupil, 5 times 10 to the minus 3, times n, 1.33, over 1.22 times the wavelength of the light, 5 times 10 to the minus 7. We put all that in, 1.5 times 5 to 10 to the minus 3 times 1.33 divided by 0.22 divided by 5. I get 16,352 meters. So that is the distance that we can resolve these headlights, 16,352 meters, which is 16.35 or 16.4 kilometers. A kilometer is about a mile is about 1.6 kilometers, so this is approximately 10 miles. So at 10 miles away, our eye would be able to distinguish the two headlights at that distance away.